we're going to look at the geometric series. Let's look at it in the form n equals k to infinity a times r to the n minus k. Now k is greater or equal to 0, and it is also an integer. So for example, when k equals 0, the series looks like the summation from 0 to infinity a r to the n. When k is equal to 1, the series is summation from n equals 1 to infinity a r to the n minus 1, and so on. We can do it for any value of k, but these will all give the same thing. It's a series of the form a plus ar plus ar squared plus ar cubed plus ar to the fourth, and so on. And this adds up to a divided by 1 minus r, provided that r is strictly between minus 1 and 1, and it doesn't add up to a finite number if r is not in that interval. So in this video, we're actually going to derive this result. We're going to derive and see why this is true. So here are a couple of things we're going to need. Let's use this notation for the series from 0 to infinity a r to the n. We're going to assume that a is not 0. If a is 0, this is a trivial case. All the terms will be 0, and we're just adding 0 to itself. We can add it as many times as we want. We still get 0. The second assumption we'll make is that r is not 1. Again, if r is 1 and a is not 0, it's like adding a to itself as many times as we want. It doesn't matter how small a is. Adding it to itself will either add up to infinity or minus infinity, depending whether a is positive or negative. So we'll make these two assumptions, and now we can proceed. We're going to need the following result that you should have learned when you studied sequences. That is, I'll use a capital N index here. The limit as capital N goes to infinity, r to the n, where r is any number other than 1, this is equal to 0 if r is strictly between minus 1 and 1, and it diverges, and diverges means it doesn't go to a finite number, if r is greater than 1 or r is less than minus 1. So we're going to need that result to derive the formula. So now let's recall that for any series, in particular a geometric series, the series is defined in the following way. The summation from 0 to infinity a r to the n is equal to the limit, let's use capital N goes to infinity, of Sn, and Sn is called the nth partial sum. So it's the sum of the first capital N terms of the series, which is a plus ar squared plus up to ar to the n minus 1. So these are n, the first n terms of the series. If we can find a formula for Sn as a function of capital N, then we'll be able to evaluate the limit. If the limit is finite, if the limit exists, the series will converge to that limit. And if the limit doesn't exist, then the series will diverge. Now, in most cases for other series, it's almost impossible to find a formula for Sn. But for a geometric series, it is possible. So we can proceed this way. Here's how we do that. So here's Sn. I'll multiply Sn by r. That gives me r times Sn, and that's ar plus ar squared, and so on. Then we get to ar to the n minus 1, and the last term will be ar to the n. Now we can subtract rsn from Sn. The left hand side will be Sn minus r times Sn. And on the right, you see that ar's cancel, ar squared cancel. Everything cancels. Ar to the n minus 1 will cancel with ar to the n minus 1. We just have a from the top row minus ar to the n from the bottom row. Now on the left, we can factor Sn out. So Sn comes out times 1 minus r, and that's equal to a minus ar to the n. And finally, Sn is equal to a minus ar to the n divided by 1 minus r. This is perfectly okay since we're assuming that r cannot be 1. So we have found a formula for the nth partial sum of a geometric series. And now the series from 0 to infinity, a r to the n, is defined by the limit capital N goes to infinity of the nth partial sum Sn. We now have a formula for it. This is the limit as n goes to infinity of a minus a times r to the n divided by 1 minus r. Since the only n is right up there, we can rewrite this as a minus a times the limit n goes to infinity r to the n divided by 1 minus r. Now remember, this limit is 0 if r is strictly between minus 1 and 1. And this limit doesn't exist if r is bigger than 1 or less than minus 1. So we can now say this will be a divided by 1 minus r if r is strictly between minus 1 and 1. And it will be undefined if r is not in this interval. And that verifies this formula. So just to make the conclusion, the series from 0 to infinity, a r to the n, which is a plus a times r squared, a times r cubed, a times r to the fourth, and so on, is equal to a divided by 1 minus r if r is between minus 1 and 1, and it diverges otherwise. So it converges if r is in that interval, and it diverges if r is greater than or equal to 1 or r is less than or equal to minus 1. For more videos